Hello, so in this video we're going to start a slightly new topic now, and we're just going to look at how kind of populations move. We're going to look at kind of movement and dispersal and kind of models that can look at that. So kind of in the last sort of section we've been looking at how we can model growth of a population. Now we're going to try and incorporate this whole idea of movement, okay, and we're going to basically first of all consider models which just consider movement, and we don't worry about kind of growth, so no birth or death rates kind of included, and that's called population dynamics. So you don't really worry about that so much. And then basically we're going to develop this whole idea into a population, into a model that includes population dynamics. So for the moment we're not considering birth or death. Okay, it's just simply straightforward movement. Okay, and the first thing we're going to look at is this whole idea of a random walk. It's going to be a very simplified random walk, admittedly, but I mean a random walk is looked at in physics, it's looked at in chemistry, biology. Essentially, okay, if you have a particle in a box, okay, and providing that particle is not acted on by external forces like heat or anything like that, so it's just going to basically be a particle inside a box. Then basically this particle will move around in some random way. Okay, there's kind of different options that it can move around in, and it will essentially, as you look at it over time, it will just look into a random pattern. Okay, it can literally move anywhere. Okay, so this is the whole idea behind kind of random walk. It's a bit like a drunk walk, I suppose. If you imagine a drunk person leaving the pub, okay, and he's going all over the place. He's wandering down the road in a kind of a weird drunk manner, sometimes called the drunk walk. Okay, but essentially just a random walk, a simple random walk. And we're going to consider this model, and it's going to be the reason why it's a simplified model is because we can only move in two directions. We can only move left or right, so it's a one-dimensional model. It's a one-dimensional model because we can only move left or right. And the whole idea is that basically we start at zero. So we start at time step 0, and basically each second we can only move one time step, so we can only move an equal step each time. So each second we can either move right or we can move left. So we can either move right or we can move left, and we can only move by one time step for each second. Okay, so fairly obviously at time equals 0, we can only be in one position. We can only be in this position. So in other words, what we're trying to do is we're trying to build up a probability idea of each step. So basically, what is the probability? So basically, what we want to try and do is build up the idea of what is the probability that we will end up at, say, time step 4. Yeah. After so many seconds. So basically, that's kind of the whole idea behind what we're building up. Well, obviously at time equals 0, there's only one place that we can be, because I'm saying at time equals 0, at the start, we can only be in one position. Yeah, that's how I'm just defining this thing. So therefore, the probability that I'm ending up in this position is 1. All right. Now, if I move left or right, I can either move left or right. Okay, I can either move left or right by one time step. Okay, but I've got a probability, of moving each way. I'm not biased towards one particular way, so I don't mind whether I move left or I don't mind whether I move right. I'm not encouraged to move in one direction over over the other direction. So, for example, I'm not encouraged to move right over moving left. I'm not kind of inclined to move any particular way over the other direction. It's just completely kind of random. I can either move left or right, and I've got an equal chance of moving both ways. There's two directions that I can move in each case. I've got two directions that I can move in each case, so therefore each direction has a probability of a half associated with it. Okay, so moving left has a probability of a half associated with it, and moving right has a probability of a half associated with it. It's a bit like flipping a coin. Yeah, it can either land on heads or tails. It's not, as long as it's not biased, it's not encouraged to land on one over the other. It's not encouraged to land on heads over it is, over tails. So, the probability of each of landing on either heads or tails. Likewise here, the probability of either moving left or the probability of either moving right is the same. I'm not encouraged to move one direction over another. So therefore, the probability for each movement is a half. Okay, so let's consider the case when t equals. Well, when t equals 1, so t equals 1. So when t equals 1, where can I end up? Well, I know that I can either move right or I can move left by one position. So I can either end up here or I can end up here. Okay, so I either end up here or end up here. So what is the probability? What is the probability that I'm going to end up in this position? I'm going to end up in this position over here. Well, the probability I'm going to end up in this position over here is a half. Because I start here and I either move left or I move right. So therefore, the probability that I am at the left position, at position 1, is going to be a half. Likewise, the probability that I'm going to end up at position 1, is, again, it's going to be a half, because I can either move left or right, and each movement has got a half associated with it. Okay, but what is the probability that I'm going to end up in this position? Well, I can't, because I know that's where I start. So I either move left or right by one position, okay? So therefore, the probability that I'm going to end up in this position is 0. I know for sure. I know for sure that I'm not going to be in this position. Likewise, I know I'm not going to be any of these positions either, but I just kind of ignore those, because obviously I can only move one time step at a time. If I start here, I can either end up here or here. I can't end up, say, at 2 or 3 or 4 or 5, and likewise for the negatives. Yeah? So basically, the positions that I can end up is either here or here. And the probability that I'm at this position is a half, and the probability I'm at this position is a half as well. So let's consider the case when time equals 2, so after 2 seconds then. So after t equals 2, so let me just try and scroll up, there we go. So at t equals 2, so after 2 seconds, okay, well, after 1 second, I'm here or I'm here, okay. Well, let's say, for example, if I'm in the left position, so I'm in this position here. Now, I can either move right or I can move left. I can either move right or I can move left. So I can either end up here or I can end up here. Okay. Likewise, I could equally have started here. Okay. And I could have moved here to the left, or I could have moved here to the right. So I could end up here or I could end up here. Okay. So therefore, where are the positions that I can end up? I can end up in this position. Okay. Let's just get rid of that. I can end up in this position, or I can end up at position 2. Okay, so I'm trying to line it up. There we go. So what is the probability that I'm going to end up at this position here? Well, basically the idea is that I'm going to end up, the probability that I'm going to end up at position 2, well, it's going to be, how do I get to position 2? Well, I have to basically move to the left and then to the left again. So in other words, I'm starting at this position here, okay, and I'm moving to the left. So therefore, I start at this position here, which already has a probability of a half associated with it, and then I'm moving again to the left, which has got another probability of a half. Okay, and that's the only way that I can get there. So I move to position 1, position -1, and then I move to the left again, and I end up at position -2. So we just move that to the left, so it lines up better. Okay, so in other words, it's a half times a half. So the probability then is a quarter. Okay, so the probability that I end up here is a quarter. Think binomial trees. Okay, binomial trees. So I end up, I start at position 0. Okay, and I can either move left or right, so to position -1 or to 1. So I start at position 0. I end up at, draw that around the other way, 1 or -1. Okay, and that's got probability of a half associated with it. And then I end up at position 1, and I can either move left or right to position 2 or back to 0 again. And likewise, I end up at position 0, and I can either move to position 0 again, so maybe if I draw that like that, end up at position 0, or I can move to the right again, which is position, -2. Okay, so those are the positions that I can end up at. Each position's got a half, and a half associated with it. So therefore, what is the probability I end up at position 2? Well, it's going to be a half times a half. Okay. Likewise, if I end up at position 0, then what's the probability I'm going to end up at position 0? Well, I can either get to 0 from, going a half. This is a half, and then down this route. So it's a half times a half, which is a quarter. Okay. Or I can go this route and then this route. So I can go down here and then down here. Okay, so that is going to be a probability of a quarter again. So it's a quarter. So it's a quarter plus a quarter to end up at position 0. So to end up at this position here, I'm going to have a quarter times plus a quarter, which of course is a half. So the probability I'm going to end up here is going to be a half. Okay. Likewise, similar kind of thing. What's the probability? How am I going to end up at position 2? I've just already done -2. That's the probability I'm going to end up here. Where I go down here and then up here. So it's a half times a half. So it's a quarter again. Okay, so that's kind of, the ins and outs of kind of what's going on. So essentially, if I just draw this probability tree in like this, okay, this has got half, it's going to end up here or here, it's got half or a half, and it can end up either here, half, I can end up here. Let's just do one more for argument's sake. So t equals 3, so after 3 seconds, I can end up here. So t equals 3, where can I end up? Well, t equals 3, I'm no longer here or here at position, so I have to consider where I am at position 2. Okay, so I'm either here or here. Well, I can either move left. I can either move left to this position here, or I can move right and end up at this position here, if I end up at position -2. If I end up at position 0, I can either move left, or I can move right again, so I can end up here. Okay, if I'm position 2, I can either end up here at position 1, or I can end up here at position 3. So these are the places that I can end up, basically. These are the places that I can end up. I can end up in these 3 places over here. Okay, so where can I end up? I can end up over here at -3. Okay, I can end up here at -1. I can end up here at 1, or I can end up over here at 3. Okay, so what is the probability that I'm going to end up in position minus? Well, again, I'm just going to draw out my tree again, because I think this kind of is a good visual indication of what's going on. So what's the probability I'm going to go down this route? It's a half. Again, this is half, half. All these probabilities, all these movements are going to correspond to a probability of a half. So what's the probability I'm going to end up over here? This is going to be probability equals, it's going to be a half. Sorry, let me just try and do this. So it's a half. I'll go down this route, then this route, then this route. Okay, so probability I'm going to end up here. That's the only way I can get to that position. It's going to be probability is equal to half times a half times a half. That's going to be an eighth. Okay, or I can go and then the probability, and then what's the probability? Similar kind of thing. And probability I'm going to end up over here is going to be an eighth as well, because I go down here, here, and then here. Right. Okay. So now let's consider how I'm going to end up at this position here, that position -1. Well, I can go down this position, then this route, and then this route. Okay, so that corresponds to a probability of half times a half times a half. That's an eighth. Or I can go this route, and then this route as well. Is that right? Yep, so that's another eighth. Or I can go this route, and then this route. That's another eighth. So therefore, probability I'm going to end up here is going to be 3/8. Okay, it's going to be 3/8. There's 3 different routes that I can take. Each route has got a probability of a half associated with it. So therefore, the total probability is going to be 3/8. Okay, so what's the probability I'm going to end up here? What's the probability I'm going to end up here? Well, I can either go this route, and then this route. So that's one out. Each path now has got probability of an eighth because there's 3 branches I have to travel down. So it's a half times a half times a half, which is an eighth. Okay, or I can go this route, so like that, and then like that. Or I can go this route, so this route, and then this route. So therefore, that's a probability of, what is it? It's a probability of 3/8 again. There's 3 out, there's 3 different ways that I can get to that route. So there's 3/8 again. Okay, and you can basically carry on going like this. But essentially what we're doing now is we're building up a tree. We're building up a tree, right? And if you look really carefully, what is this? It's a spatial distribution. Basically, a spatial distribution is just the distribution or the positions which you can end up in space. Okay, so it's a kind of a pattern of where you can end up in space. And this is what's known as a spatial distribution. Okay, and it, if I just sort of draw it out again, just corresponding to probabilities. So if I just draw it out kind of without all the lines and everything. So we've got 1, half, 0, half. Then we've got quarter, 0, half, 0, quarter. And then again, this one here is going to be an eighth, 0, 3/8, 0, 3/8, 0 and a quarter. And I'm just basically saying, well, the probability that we're going to end up in this position here is, at time equals 3 is 0, because we can't, because that's where we were in the last position. Okay, so basically, we can carry on going like this. Sorry, that's an eighth, isn't it? So basically, we can carry on going like this. This is a special type of distribution. And if you look really, really carefully, this is a binomial spatial distribution. The reason why it's binomial is because binomial, the prefix bi means 2. Okay, so if there's 2 positions that we can end up at, then therefore it's a binomial distribution. It's a binomial distribution, and this is discrete. Okay, and the reason why it's discrete is because we can only end up at sort of finite values. Okay, so the finite values, you can only end up at position 1 or 2 or 3. You can't end up at positions between a position. Okay, so it's a discrete distribution, and it's a binomial distribution. Okay, and we can work out these probabilities by basically just using our combination. Okay, so how many ways are there of choosing? Are things from n? Are things from n objects? Okay, and that's kind of the whole idea behind this. So basically, the simple random walk is really, really useful because it kind of models, it can be modelled by a binomial distribution.